geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this: a body is moving unidirectionally under the influence of a source of constant power. A body is traveling in the single direction under the influence of constant power source. Okay, the square of its displacement in time t is proportional to. You are asked to decide what is the relation between the square of the displacement and time period. Okay, for that let us take the work energy theorem. According to work energy theorem, work equal to kinetic energy. So kinetic energy equal to half into m into v square, and power p equal to rate of doing work, that means work by time. From this, work equal to power multiplied by time. In the place of work, I am writing power multiplied by t equal to half m v square. From this, you can write v square equal to 2 pt by m, or v equal to 2 pt by m whole power 1 by 2. Can also be written as v equal to 2p by m power 1 by 2 into t power 1 by 2. Okay. Now, as we all know, the velocity v equal to ds by dt. In the place of v, let me write that value, ds by dt equal to 2p by m power 1 by 2 into t power 1 by 2, or ds equal to 2p by m power 1 by 2 into t power 1 by 2 into dt. So this is the small displacement of the body with small time period dt. Let us take another slide. ds you got 2p by m power 1 by 2 into t power 1 by 2 into dt. Since that is a small displacement with small time period dt, now let us integrate it. Upon integration, integral ds equal to 2p constant, m also constant, power 1 by 2. No, constant can be written outside in the integration. Integral t power 1 by 2 dt. Okay. As we all know, integral dx equal to x. Similarly, integral x power n dx equal to x power n plus 1 by n plus 1. Simple mathematics. Integral dx I can write as x, but here ds. Better to printing mistake. This is the ds equal to s 2p by m whole power 1 by 2 constant, t power 1 by 2 plus 1 by 1 by 2 plus 1, 1 by 2 plus 1, s equal to 2p by m power 1 by 2 into 2 by 3 t power 3 by 2. Simple mathematics. Then s equal to 2p by m power 1 by 2 into 2 by 3 power 2 by 3 t power 3 by 2. Here this quantity is constant. Then I can write s is equal to a constant c into t power 3 by 2, where c equal to I am writing 2p by m power 1 by 2 multiplied by 2 by 3. Anyhow, s can be written as s is directly proportional to t power 3 by 2, or s power 2 is proportional to t power 3. So square of the s is proportional to cubic power of time. Look at the options. Cubic power of e. Option A itself is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Asking like this: an elastic string of unstretched length L and force constant K is stretched by a small length X. Unstretched length of the spring means, or elastic string means, the length of the string before you are applying the force. Okay, it is extended to a small displacement X. It is further stretched by another small length Y. The work done in the second stretching is. Here also you need to apply the work energy theorem from work energy theorem. For elastic string, you can write that work equal to minus delta U. It is equal to minus, right, final energy of the string minus initial energy. The energy which is stored in the elastic body is strain energy. Of course, this can be also written as Ui minus Uf. So work equal to Ui minus Uf. Here Ui equal to half into K into x square. Initially it is stretched by x. Uf equal to half into K into x plus y whole square. It is further stretched by length y. That's why it is x plus y whole square. Then W equal to Ui. Ui is half K x square minus half K x plus y whole square. Now you need to expand it. It is equal to half K x square minus half K into x square plus y square plus 2xy. 2xy. Let us take another slide. Work equal to half kx square minus half k into x square plus y square plus 2xy. Is it correct? 2xy. Now let us simplify it. Work equal to half into kx square minus half k x square minus half k y square minus half k 2xy. Now let us cancel the first two quantities. Work equal to minus half ky square minus half k. Of course this 2 to cancel. I can write the kxy. Kxy. Okay. Then work energy, right, done by elastic force. Work energy done by elastic force equal to minus W. Therefore, right, it can be written as W equal to minus half ky square plus kxy. This negative sign is cancelling. Then work equal to, right, half ky, let us write outside. Then it is y plus 2x. So that is the work. Half ky, look at the options. Half ky plus 2x plus y. 2x plus y. Therefore, option B itself is absolutely correct. Very, very important problem. I can say 5-star problem. This kind of problem can be repeated. Okay. Understood clearly? Yes. Then let us take the another important problem. It is asking like this. A small block of mass m is kept on a rough inclined surface of inclination theta fixed in an elevator. For that, let us take the elevator. This is the elevator. In this elevator, there is a small rough inclined plane. There is a small rough inclined plane like this. Over that inclined plane, here angle is given theta. a small block is kept. Let us place that a small block. That small block might be like this. The mass of that block is given m. Okay. The elevator goes up with uniform velocity v, and the block does not slide on the wedge. The elevator goes up with uniform velocity. Elevator is moving in this particular direction with a velocity v, and the block does not slide on the wedge. The work done by the force of friction on the block in time t will be, what is the work done by the force, right, or by the frictional force on the block? That is what it is asking. Now for that, first let us write the work formula here, otherwise here itself. Look at the force which is acting here. The force is acting, a minute, force is acting along the plane. Frictional force acting along the plane, right? That is the what this is the direction of frictional force F. It is making an angle theta. Since opposite angles are equal, this is the theta. Then it is developing two component of forces. This is the horizontal component of force F cos theta, and this is the vertical component of force F sin theta. F sin theta. Okay. Then work equal to what? Then work equal to that F sin theta into S. That is Fs sin theta. Fs sin theta. But F is the force causing for motion. Look at the plane once again. This is the plane. Over that rough plane, a block is kept somewhere here. No, this is the normal reaction direction. The weight is acting vertically downwards with a magnitude mg. Then it is developing two component of weights. This is the mg cos theta, mg sin theta. Right? That means here F equal to mg sin theta. In the place of F, I can write mg sin theta. Mg sin theta into sin theta into S. It is written as mg sin square theta, mg sin square theta into S. But as you know, V equal to S by T. From this S equal to V T. It is equal to mg into Vt in the place of S into sin square theta. That is the work. Look at the options. Look at the options. mg Vt sin square theta. Option C is absolutely correct. Understood clearly? I am trying to explain the each and every point at your understanding level. Okay? Yes. Similarly, let us take the another important problem. Okay? Look at the screen. It is asking like this. A light inextensible string that goes over a smooth fixed pulley as shown in figure. Inextensible string means the string which does not go for elongation, that is connected to two blocks with the help of a frictionless smooth fixed pulley means frictionless pulley. Look at the mass of the two blocks. Connects two blocks of masses 0.36 kg and 0.72 kg. Among the two blocks, one is bigger block maintaining capital M mass, small m. Small m is given 0.36 kg and capital M is given 0.72 kg. Given acceleration due to gravity 10 meter per second square, find the work done in joules by the string on the block of mass 0.36 kg during the first second after the system is released from rest. After the system is released from rest means initial velocity u equal to 0, time t equal to 1 second. Here work done by the string, work done by string on on block of mass on block of mass 0.36 kg is how much? That is the question. Very simple. Work done equal to tension developed in the string multiplied by displacement of the string. For that, we need to decide the tension and the distance traveled by the string. For that, let us take the elongated diagram. Once again, let me mark the weight of the bigger block, capital Mg. It is acting vertically downwards, and the tension is acting like this. This is the small mg acting vertically downwards. Tension is same because the same string is connected to both blocks. Okay. Definitely here the string is moving towards the bigger block side with acceleration a. By the time bigger mass is moving down, smaller block is moving upwards, but maintaining constant acceleration. With this, you can decide the tension for bigger block. For bigger block, let us write the force balance equation. Here mg for bigger block, capital Mg more than tension. Therefore, mg minus T must be equal to mass times the acceleration. Similarly, you can write for smaller block or lighter block. For lighter block, here for lighter block, T is more than small mg. Therefore, T minus small mg must be equal to mass times the acceleration. From this, tension T equal to mg plus ma, m into g plus a, m into g plus a. From this, capital T equal to mg minus ma, right? Ma. Okay, in the place of T, let me write that value. That is mg plus ma equal to capital Mg minus capital Ma. Let us write m terms one side, g terms other side. Capital Ma plus small ma equal to capital Mg minus small mg. A into capital M plus small m is equal to g into capital M minus small m. Therefore, acceleration equal to g into capital M minus small m by capital M plus small m. So, acceleration equal to g into capital M 0.76 minus 0.3, 0.72 minus 0.36. 0.72 should be very careful. 0.72 0.72 minus 0.36 divided by 0.72 plus 0.36. It is equal to 0.36 by 1.08 times the g. That is the acceleration. So finally we got acceleration a equal to 0.36 by 1.08. I can write 1 by 3. It is g by 3. That's the acceleration. Okay. You substitute that acceleration here for getting the tension. Let us take another slide. Here tension T equal to what we got small m, small m, small m into g plus a. Small m 0.36 g plus a equal to you got g by 3. It is equal to 0.36 3g 3g plus g by 3 equal to 0.36 4g by 3. There is the tension, right? G can be taken 10. Then uh, for finding the work done, displacement is required. Displacement of the block of mass 0.36 kg equal to ut plus half AT square. It is given that block is starting to move. Block is moving from starting. U equal to 0, S equal to half AT square. So it is equal to half into A equal to what? Look at the A value. A value is G by 3. A value G by 3 into T 1 square. It is G by 6. Then work done on the smaller block by the string equal to tension multiplied by displacement. Tension is how much? 0.36 into 4 into G by 3 into G by 6. You simplify this value. It is equal to 0.36 into 4 into 10 into 10 divided by 3 into 6. So here this 10 into 10, 100 into what 0.36, 36 is equal to 36 into 4 by 3 into 6. It is 6 times. 3 2 times. 4 into 2, 8 joules. 8 joules or Newton meter. That's the answer. That's the work done. Look at the options. Look at the options. 8 joules. Option C is absolutely correct. Are you following clearly? Yes. Similarly, let us take the another important problem. Look at the screen. It is asking like this. If the unit of force and length be each increased by 4 times, then unit of energy increased by, as you know, energy equal to, work is also kind of energy. It is equal to product of force unit and length unit. Length unit. Unit is joule. If force is increased by 4 times and the length is increased by 4 times, 4 times, then the energy is increased by 16 times the FL. That means energy is increased by 16 times. That means when the force is increased by 4 times, or length is increased by 4 times, the energy is increased by 16 times. Option A is absolutely correct. Okay? Simple question. Logically, you can decide the answer. Similarly, look at the another important question asking like this. Which of the following must be known in order to determine power output of the automobile? As you know, power output of the automobile equal to work done per time. So both work and time both are required for deciding the power. Look at the options. Final velocity and height? No. Mass and amount of work performed? No. Force exerted and distance? With force and distance you can decide the energy, work energy, but not power. Work performed and elapsed time? Yes. Right? How much time the work is developed? That is giving the power. Option D is absolutely correct. Okay. Similarly, look at the another important question asking like this. A massless platform is kept on a light elastic spring as shown in figure when a sand particle of mass 0.1 kg is dropped on the pan from a height of 0.24 meters. When h1 height of drop of sand particle is 0.24 meters, the particle strikes the pan and spring is compressed by 0.01 meter. Then the deflection of the spring x is given 0.01 meter. From what height should be the particle be dropped to cause a compression of 0.04? For having the deflection of the spring is 0.04 meters, what should be the r at from what height the sand particle should be dropped? That is the question. Now by applying the what work energy theorem, you can decide the answer. From work energy theorem, from work energy theorem, as you know, half mv square must be equal to half kx square. As you know, v equal to root over 2gh or v square equal to 2gh. From this I can write that half into m into 2 into g into v square, right, h equal to half into k into x square. You know, this 2 is cancelled, mg into h equal to half into kx square. You know, mass is remaining constant, g also constant, k also constant. Then I can say h is proportional to x square. Since h is proportional to x square, I can say that h by x square is proportional to 1, or h by x square equal to a constant. Or I can also say, right, h1 by x1 square equal to h2 by x2 square. Then height of sand particle to be dropped, right, equal to h1 by x1 square into x2 square. Look at the h1 value. h1 value 0.24 by x1 value 0.01 into 0.04, x2 is 0.04 whole square, right, whole square. This is whole square. Okay, now you simplify that part. Here it is, no, it can be written as 0.24. I can write as 24 by 100. This I can write as 4 by 100, or 4 square by 100 square. 4 square by 100 square, listen carefully, divided by 1 by 100. 1 square by 100 square. This 100 square part is cancelled. Okay. Now here 4 square into 24. 4 square is 16. 4 square 16. 16 into 24. Finally answer is h2 equal to you got h2 you got is 24 into 4 square. 24 into 4 square by what? Take minute. By 100. So here it is, 16 into 24. 24 into 16. 360. Right. 380. 384. 1 minute. It is 384. 384. It is equal to 384 divided by 100. How much? 3.84 meters. So it has to be dropped. For having the deflection this much, it has to be dropped from a height of 3.84 meters. So look at the options. Approximately A can be selected. Okay, approximately A is correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. The potential energy for a force field F bar is given by, here potential energy is given in terms of x and y, cos x plus y. The force acting on a particle at position given by coordinates. Look at the coordinate. X is given 0, the x value, and y is given pi by 4, the y value. Okay. Then let us write the force general formula. Force general formula is minus dou u by dou s. S is the distance. Then force along x direction equal to what? Minus dou u by dou x equal to minus dou by dou x. Here u given cos x plus y equal to minus differentiation of cos theta minus sin theta minus cos x plus y minus and minus plus, it is equal to sin x plus y. So finally we got fx equal to sin x plus y. The same way fy also equal to sin x plus y. Then fx value at 0 comma pi by 4. Let me write it clearly. Fx value at 0 comma pi by 4 equal to, right, equal to sin 0 0 pi by 4 means 5 by 4 45, sin 45 1 by root 2, it is 1 by root 2. Similarly fy the coordinate 0 comma pi by 4 also equal to 1 by root 2. Then the net resultant force is equal to fx I cap plus fy j cap. Fx is 1 by root 2 I cap plus 1 by root 2 j cap. Simplify this value, 1 by root 2 into I cap plus j cap. That is the answer. Look at the options. Look at the options. Option B is absolutely correct. 1 by root 2 I cap plus j cap. Understood clearly? Simple problem. Similarly, let us take the another important problem. Asking like this. A long string is stretched by 2 centimeters and the potential energy is V. That means V1 equal to V at x1 equal to 2 centimeters. If the spring is stretched by 10 centimeters, x2 equal to 10 centimeters, then what is the potential energy? V2 is how much? That's the question. Very simple. As we all know, potential energy, right? V equal to half into k into x square. Right? From this I can write that V by x square equal to k by 2. Here k is constant, k is the stiffness, that is the remaining constant. Therefore k by 2 is constant. K by 2 constant means V1 by x1 square equal to V2 by x2 square. From this V1 is V, x1 square is 2 square, V2 unknown value, x2 is 10 square. From this V2 equal to 10 square by 2 square into V. 10 square is 100 by 4 into V. It is equal to 25 times the V. That means final potential energy is becoming 25 times the initial potential energy. Option D is absolutely correct. Okay, na? Similarly, let's take the another important problem. Look at this problem. A chain of mass capital M is placed on a smooth table with 1 by n of its length hanging over its edge. The work done in pulling the hanging portion of the chain back to the surface of the table is, it is like this. Look at the chain on the table. This is the chain on the table. Chain on table. A small part is hanging from the surface of the table. That hanging length is given L by n times, L by n times. Then the remaining one is, remaining length is L minus, total length L minus L by n. Since the chain is maintaining the uniform cross section, therefore m by m by n part of the m by n part of the m by n part of the mass is hanging. The remaining one, capital M minus capital M by n part is on the table. Okay. Then is asking the work done in pulling the hanging portion of the chain back to the surface of the table. Here work done means potential energy of the center of mass of the chain hanging, right? Hanging part. So work done equal to potential energy of center of mass of the hanging part. Hanging part. What is the hanging part mass? Capital M by n, and G right? Distance, right? Potential energy of center of mass. If L by N is the total hanging part, then what is the center of mass location? Center of mass location, let me mark here. This may be the center of mass location. Center of mass of L by N equal to L by 2N. L by half of that one. L by 2N. You simplify it. So finally it is equal to mgl by 2n square. That is the work done in pulling the hanging portion of the chain. Mgl by 2n square. Look at the option D. Option D is absolutely correct. Okay, na? Understood clearly? Simple problem. Similarly, let's take the another completed. All the problems what we prepared completed. I hope all of you clearly understood all the problems what we discussed. Understood or not? Yes. Thank you. Thank you for watching. Okay.
Geobyte.